My name is Dr. Maxwell Sante. I'm a senior research scientist and rice breeder at the CSIR-Crops Research Institute in Kumasi, Ghana. Welcome to our confined field trial field for NUE rice. NUE is a transgenic rice that has been transformed to use nitrogen more efficiently. So rice is very important in Ghana. It is now a staple food, and we eat over 1 million tons of milled rice every year. But unfortunately, we have to import about 50% of that, using a whopping $500 million US every year. And for a small country like Ghana, that's a lot of money for us. One of the biggest constraints to rice production in Ghana is that our soils are depleted, and therefore when farmers plant, they are not able to get optimum yields. And then even when fertilizers are available, many of our farmers are resource poor farmers, so they are not able to apply the right amount of fertilizer to their field. So what this trial is helping us to do, our aim is to come out with a GM rice variety that is able to use fertilizer more efficiently. So we have found that most farmers either do not apply fertilizer at all, or they apply about 1/3 of the recommended rates. So we have tested these lines, these events which are nitrogen use efficient at levels of 30, 60, 90, and even at 0. Okay, and then we have done many confined field trials on many lines which have been transformed to use nitrogen more efficiently, and we have eventually identified our lead event, which we call NUE 12. Okay, so it is NUE 12 that is our lead event, and the current trial is to help us validate the yield advantage that we got for NUE 12 over the wild type on smaller fields. Because we were testing many lines, we had to use plot sizes of about 4 meters square, and we found yield advantage for 15 to 30% on some of the fields. So these are bigger fields, which is 10 meters square, which is helping us to validate the yield advantage that NUE 12 has over Nereka 4. So this field behind me was planted on the 28th April 2021. So the fields are around 57, 58 days old. Okay, so they are around panicle initiation now, and that's, we are now coming to apply our second split of N fertilizer. We already applied the first split at the beginning of the experiment. This is our site manager, Daniel. Daniel will show us a few of the plots.
This is our efficacy trial plot, and this plot shows the 90 kg treatment of fertilizer for NUE 12 and 90 kilos for Nereka 4. And
so these two adjacent plots, they are both 30 kg N fields. This one on my left is for NUE 12, and this is for the Czech Nereka 4. So if you can see clearly from here that the NUE 12 at this low fertilizer rates appears to be doing much better than the Czech. So if we are able to see this on the field, it just shows that the gene appears to be working, and therefore it can reflect in the yield. At this stage, only half the rate has been applied, so we are going to apply the second split. But what I want to show clearly is that these two adjacent fields, this is for the control, the Nereka 4, and this is for NUE 12 at 30 kg N per hectare, and this appears to to be doing much better than the check. As you can see from here and here, this is our 90 kg plot. This is our 30 kg plot, and the last one is our 0 kg. So you can see clearly that there's a difference. The 90 kg plots are greener, followed by the 30 kg, and then the 0 kg. But I'll have to add that at this stage, we have only applied half of the N. This is our first split. You can see clearly that the 90 kg plus are doing better than the lower rates.